All right, so this is going to be the walkthrough for the product rule and quotient rule homework. And since we haven't done derivatives of really anything other than algebraic functions here, no trig functions, no exponential, no logarithmic, these are going to be pretty basic problems. We're going to do a lot more practice with these rules once we have other, other derivative forms that we could take. So we're going to start off here with this one. We're going to recognize that since this is a quotient of two functions, that we're going to use the quotient rule. Right? And so whenever we do the quotient rule, I think it's best for us to kind of give ourselves a little note that it's u divided by v, and then we can use the quotient rule formula, which is v times the derivative of u minus u times the derivative of v, all divided by v squared. And then we just kind of plug it into our formula that we've proven in class. So f prime of x in this case is going to be v, or x cubed plus 4, times the derivative of u. Well, the derivative of u is the derivative of x squared minus 1, which using the power rule, the derivative of x squared is 2x, and the derivative of minus 1, that's a constant, so it's just 0. So we'll do v du minus u, which is x squared minus 1, times the derivative of v, which is just 3x squared, all divided by x cubed plus 4 squared, right? Our denominator squared. So I'm just going to go in here. This is our v squared. Here is our dv. Here is our u. Here is our du. And here is our v. So we can kind of see where everything is, right? Now we'll just distribute and simplify. So this ends up becoming 2x to the 4th when we multiply that out. 2x to the 4th plus 8x. And then we'll have over here we'll have minus x squared times 3x squared, which will be minus 3x to the 4th. And then we'll have a minus 1 times 3x squared, which will be a plus 3x squared. It's still all over x cubed plus 4 squared. And we'll combine like terms there. 2x to the 4th minus 3x to the 4th is negative x to the 4th. We've got plus 3x squared, and we've got plus 8x, all divided by x cubed plus 4 squared. And so that's our first problem. So just a bunch of algebraic simplification after using the quotient rule. For our second one, we'll note that this is a product of two functions, so we're going to go ahead and use the product rule this time. Now, there is another way to do this one other than the product rule, but since we're supposed to be practicing using the product rule, we won't do that. We could just distribute all this out and get a nice little polynomial, and from there we can just use the power rule. But since we're practicing the product rule, we're going to use it. The product rule is u times the derivative of v plus v times the derivative of u. And of course, we can interchange those. We could do v du plus u dv if you wanted to. It doesn't really matter since addition is commutative. So we'll start with our f prime of x should be u, x squared minus 3, times the derivative of v. Well, the derivative of x to the 4th plus 1 should just be 4x cubed, because that's the power rule, and the plus 1 is a constant, so that goes away. So there's u dv plus v, x to the 4th plus 1, times the derivative of u, which is just 2x. And so we can distribute this all out. In fact, I'll make a little note here. This is u. This is the derivative of v. This is v. And this is the derivative of u. And so now when we distribute it out, 4x cubed times x squared is 4x to the 5th. And then we have a minus 12x cubed. And then we'll do plus 2x to the 5th plus 2x as we distribute that 2x to the x to the 4th plus 1. Combining the like terms, 4x to the 5th and 2x to the 5th, gives us 6x to the 5th minus 12x cubed plus 2x. And so there's our product rule. All right, for this next one, again, we've got a quotient of two functions here. And so we'll use the quotient rule. As we go through and do this, I'm going to still write u over v. And we'll start off with g prime of x is equal to v times the derivative of u. And the derivative of that numerator there is 3x squared minus 4x using the power rule. And the plus 1 falls off because it's a constant. So v du minus u, so that would be our x cubed minus 2x squared plus 1, times the derivative of v, which is just going to be 2x minus 1. Right? Because the derivative of x squared is 2x, the derivative of minus x is minus 1, and the derivative of negative 1 is 0. And now it's all over our denominator squared. We can start going through here and we can distribute all this stuff out, which is going to get a little bit messy, but that's okay. 3x squared times x squared, that's going to be 3x to the 4th. And then the x squared times the minus 4x is going to be a minus 4x cubed. And then the minus x times the 3x squared will be a minus 3x cubed. And the minus x times the minus 4x will be a plus 4x squared. Minus 1 times 3x squared ought to be minus 3x squared. And minus 1 times minus 4x ought to be plus 4x. And then for the second part of it, we're going to recognize that we have a minus sign here. So we're going to just change the signs of everything once we distribute. So x cubed times 2x is 2x to the 4th. So we'll have a minus 2x to the 4th. X cubed times negative 1 is negative x cubed. So we'll have a plus x cubed. Negative 2x squared times 2x is negative 4x cubed. So we'll have a plus 4x cubed when we change that sign. Negative 2x squared times negative 1 is positive 2x squared. So we'll get a minus 2x squared. And then we've got 1 times 2x, which is 2x. So a minus 2x. 1 times negative 1 is negative 1. So we'll have a plus 1 there. And it's still all over x squared minus x minus 1 squared. So we will then go right ahead here and we will combine all the like terms. So looks like, cross these out as we go. We've got a 3x to the 4th and a minus 2x to the 4th, which should give us x to the 4th. We've got a minus 4x cubed and a minus 3x cubed, which is minus 7x cubed. And then we're going to add 1x cubed, so that'd be minus 6x cubed. And we're going to add 4x cubed, which is going to make it minus 2x cubed. Then we've got a plus 4x squared and a minus 3x squared. And that's going to be x squared. And then we're going to subtract 2x squared from that. So now we'll have a minus x squared. And we've got a plus 4x with a minus 2x, which ought to be a plus 2x. And we're left with just the plus 1. And if you gave me that as an answer, that would be perfectly acceptable. One thing that's kind of cool about this one in particular here is that numerator actually factors down really cleanly. It's actually evenly divisible by x squared minus x minus 1. In fact, it happens to be x squared minus x minus 1 times x squared minus x minus 1. And so we can just quickly go through and see that that's the case. Right, x squared, x squared times x squared, that's my x to the 4th. We've got an x squared times a negative x, that's a negative x cubed. Plus we have a negative x times an x squared, that's negative 2x cubed, so that's this term. We've got x squared times negative 1, which is negative x squared. And we've got another x squared times negative 1, which is negative 2x squared. Plus we've got negative x squared times negative x times negative x, which is positive x squared. So we had negative 2x squared and a positive x squared, which is negative x squared. And then we've got negative x times negative 1. and -1 times -x. Those are both positive x's, so there's your 2x. And a -1 times a -1 gives you the plus 1. So really what we've got here is actually x squared minus x minus 1 squared over x squared minus x minus 1 squared, which should simplify down completely to just 1. So the derivative of that is 1. And we could have seen that from the beginning if we'd taken the done the long division of that, we would have seen that we actually end up just getting x plus maybe some constant, and so the derivative would just be 1. But again, like I said, I would have accepted this answer right here without doing that factorization. But kind of cool that it turned out to be 1. All right, we got a couple more of these here. We'll do 3 more of them. So this one is, again, a product rule problem. And once again, we could, if we really wanted to, we could just distribute this out and use the power rule, but we're going to use the product rule because that's the point of this assignment. So this is u and this is v, and we're going to once again do u dv plus v du. So u is x squared minus x minus 4, and dv is just 15x to the 4th. Right, taking the derivative of 3x to the 5th using the power rule, and the derivative of 7 is 0. And then we'll add to that 3x to the 5th plus 7 times the derivative of u. Derivative of x squared is 2x using the power rule. Derivative of negative x is minus 1 using the power rule. And the derivative of minus 4 is 0 because it's a constant. We'll just distribute and combine some like terms here. So x squared times 15x to the 4th would be 15x to the 6th. The minus x times the 15x to the 4th will give us minus 15x to the 5th. And the minus 4 times the 15x to the 4th will give us minus 60x to the 4th. And on the other side here, we've got 3x to the 5th times 2x, which will be plus 6x to the 6th. And we'll have 3x to the 5th times -1, which will be minus 3x to the 5th. Plus 7 times 2x will be plus 14x. And plus 7 times -1 will be minus 7. And we'll just combine like terms. Looks like we've got a couple of x to the 6th terms, so we'll end up with 21 of those, 21x to the 6th. Looks like we've got a minus 15 and a minus 3x to the 5th, so that'll be minus 18x to the 5th. And we got a minus 60x to the 4th. No cubes, no squares, just a plus 14x and a minus 7. And that ought to do it. Okay, for this one, we're going to use a special application of the quotient rule, which is called the reciprocal rule. The reciprocal rule, as we talked about in class, normally we write this as like a constant divided by some function g, and the derivative of that, the derivative of a constant divided by g of x is equal to negative c times g prime of x over g of x squared. And so we can, in fact, we'll just real quickly show why that's the case, right? If I try to take the derivative of this using the quotient rule, use the quotient rule on that, we should be able to see that, you know, if it's u over v, we should start with v times the derivative of the constant. Well, what's the derivative of a constant? It's 0. So we have v du minus u, that'd be c, times the derivative of the denominator, that's g prime of x, all over the denominator squared. And we should see that, well, any function times 0 is just 0, and we're left with negative c times g prime over g squared. So we can use the quotient rule for this problem, or we can use the application of the quotient rule that is the reciprocal rule, which I think is going to be a lot easier. Our constant is 2, so we're going to have negative 2, and then we're going to multiply that by the derivative of the denominator. The derivative of 3x squared is 6x, and the derivative of minus 5, that's a constant, so it goes away, it's 0. And then we're going to divide that by 3x squared minus 5 squared. Multiply the top out, you get negative 12x over 3x squared minus 5 squared. And that's our final answer. All right, we've got one more to go. It's kind of a long and messy one. We're going to see if I can manage to fit this all in one page. If not, we'll have to go to a new one. Again, it's a quotient rule. So let's see if I can fit my initial thing up here. Maybe if I can, we'll be able to make it through on the same page. So it should be the denominator, v, times the derivative of u. So that's going to be 4x cubed for the derivative of x to the 4, minus 6x for the derivative of the minus 3x squared, and plus 5. So there's v du, minus u, which is going to be x to the 4th minus 3x squared, plus 5x minus 1. So there's v du minus u, and then dv should be the derivative of 3x cubed is 9x squared. The derivative of minus 2x is minus 4x. And the derivative of plus x is plus 1. So we're looking at, just write this out again. No, actually, let's not forget the most important part is our denominator squared. So we've got v du minus u dv all over v squared there. So now as we do the distributing, it's gonna get really long and messy here. Try to use a different color here. 3x cubed times 4x cubed is going to be 12x to the 6th. And then we're going to have, I'm going to just kind of try and line up some terms that match as we go. So I got 12x to the 6th. The 3x cubed times the negative 6x is going to be negative 18x to the 4th. We're going to have a plus 15 x cubed. We're going to have a minus 8 x to the 5th. We're going to have a plus 12x cubed. We're going to have a minus 10 x squared. We're going to have a plus 4x to the 4th. We're going to have a minus 6x squared. Now we're going to have a plus 5x. Clearly, I'm going to be out of room here, so I'm going to do the second ones here in black. And remember that they all have a minus sign in front of them. So as we do this, we're going to have to make sure to distribute that minus sign. X to the 4th times 9x squared should be 9x to the 6th, but it's going to become minus 9x to the 6th. So I'm going to put that over there. So there's our minus 9x to the 6th, just to match it up with the other x to the 6th. X to the 4th times negative 4x should be negative 4x to the 5th, but because of the negative out in front, should become a positive 4x to the 5th. So I'll just line that one. Oh, that one's not a 5th. Let's line it up with a 5th, just so I got them in the same place. And then we're going to have x to the 4th times 1, which is x to the 4th, but it'll be a negative x to the 4th because of the negative between them. 3x squared, sorry, negative 3x squared times 9x squared is negative 27x to the 4th. We'll flip the sign of that to make it a positive 27x to the 4th. I'll put that one there with that one. Negative 3x squared times negative 4x is going to be a positive 12x cubed, which will become a negative 12x cubed. So throw in the negative 12x cubed. That's nice. Those ones are going to cancel out there, looks like. And then what do we still have? We still have the negative 3x squared times the 1, which is going to be a negative 3x squared. And then it'll become a positive 3x squared there once we change the sign. We're going to have a 5x times a 9x squared, which is going to be 45x cubed, but it'll become a minus 45x cubed. because of the minus sign. The 5x times the negative 4x is negative 20x squared, so that'll be a plus 20x squared. And the 5x times the 1 is 5x, which will become a minus 5x. And now we're just down to a negative 9x squared, which becomes a positive 9x squared because of the minus sign. A positive 4x, which becomes a minus 4x. And a minus 1, which should become a plus 1 down there at the end. So quite a few terms to combine here, and we'll note that this is all still over this denominator, but I'm just going to say that's a little side work, and we'll say equals my 9x, negative 9x to the 6th, and my 12x to the 6th should give me a 3x to the 6th. And then I've got negative 18x to the 4th minus 1x to the 4th is negative 19. Oh, actually, shouldn't go to the 4th, so we should go to the 5ths first. So here's a minus 8x to the 5th with a plus 4x to the 5th. That should be minus 4x to the 5th. Then we'll do our 4th. So negative 19x to the 4th there. If I add another 4x to the 4th to that, that's negative 15x to the 4th. Plus 27 ought to be a plus 12x to the 4th. With our cubes, we already had a couple that just canceled out, the plus 12 and the minus 12x cubed. And then we've got these two, which should combine together to make a minus 30x cubed. With our squares, we have quite a few of those. We've got a minus 10 and a plus 3, so that would be minus 7x squared. Minus 7x squared minus another 6 will be minus 13x squared. If we add 20 to that, we'll be at 7x squared plus another 9. Should put us at 16x squared. And we're just down to the last couple terms here. 5x and a minus 5x should cancel. And we're left with a minus 4x and a plus 1 at the end. So minus 4x plus 1. And after all that work, don't forget to put it over your denominator squared. It'd be a shame to go through all of that pretty heinous algebra and then forget to have your denominator lose a point for that. So there we go. Kind of a pain, but that's the derivative. And that is the product and quotient rule homework assignment. All the problems worked through.